today I'm going to do a video about the rest of the story concerning our math competitions. And to understand why we do so many math competitions, I think it's important for you to understand our whole philosophy behind teaching mathematics. For us, mathematics is primarily a problem-solving task. Learning how to think deductively. Get a certain body of information with a certain number of facts. You figure out what is the line of thought and what mathematical tools you need to solve a problem. One I just gave to the children was, can you make 36 cents out of 3 coins? Okay, I think 36 cents, 3 coins. Let's get as big as we can. A quarter will work. How about a dime? Yep, that makes. How about a nickel? Nope, won't work. I need a penny. So you had to look at the problem and make deductions. Okay, let me try the different coins, see which ones work correctly until I come up with the right answer. Or another one that I gave them is you buy a puppy and you put the puppy in the backyard and you put the puppy on a leash that's 10 feet long. And the question is, how many square feet does the puppy have to play in the background if it's on the leash? All right, you have to realize, well, that puppy can do a circle that has a radius of 10, a diameter of 20. I see, to find the area, I know what I need. I need to know how to find the area of a circle. So pi 3.14 or 22/7 times the radius, which is 10, then you get your answer. In both of those, you had to think about how to approach the problem, and then you had to think about what tools do you need. And the more advanced are the problems, we have students competing in national math competitions, the more challenging are the competitions, the more you need tools. Or on a lesser scale, the more you want to move up in 5th, 6th, 7th, and 8th grade and take more rigorous coursework, then the more you need tools. You have to have your facts memorized, no matter what is said publicly, that you don't have to have your facts memorized. I've seen commentary like that in magazines. It's ridiculous. You got to know your facts. You have to know your computational skills. Now, that's not math. Math is problem solving. It's using those tools to be able to break down problems and figure out what operations do I need to come to a conclusion. So now let me just say a little bit about some of what we've done in the past with that. We have these wood math books. I discovered this way back before I even started Birchwood School. Kids did not have enough practice with their computational skills, and children who knew their computational skills, say by the 3rd or 4th grade, they needed advancement. They could do even more complicated computational skills. So we did a rudimentary, when I was teaching in public schools, a rudimentary wood math program where I just collected hundreds and hundreds of problems. Why? For practice. There was no shortcut to learn computational fluency or to learn your facts. You just have to work on it. So that's kind of the backstory on that wood math program that we've had, and we've made it better. In fact, we have the newest edition will be coming out this summer. Mrs. Uechi has been working on it, and Mr. Sproul. So let me say a little bit about competitions. Why all the competitions? And we have a lot. The younger children do the Noetic, they do Continental Math League. As they get older, they learn to do Math Olympiads and then Ohio Math League. And probably the top one is Math Counts. That's the most challenging. It's really for middle school students, but we have children even younger who have the tools and are able to solve them. We do them because they are practicing problem solving all the time. You practice, you just get better at it. Not only are you're learning to use their computational skills or their facts, but they're learning more and more strategies, how to create a chart, how to use drawings, how to make graphs, to take the information in the problem and arrange it in a way that you can solve it. That's deductive thinking again. And in that deductive thinking, then they figure out, okay, what tools do I need? What formulas do I need? What postulates do I need in order to attack that problem and to solve it? And of course, kids get better at it. You keep practicing, you get better and better and better. Even children who struggle at first, if they've transferred in or they're just starting some problem solving in the 3rd or the 4th grade, you practice, you begin to learn the strategies, you begin to learn the way of thinking, and pretty soon you're able to solve problems. You're successful. Oftentimes, maybe many of you have heard this, someone will ask, why do I need math? Why do I need algebra? Why do I need geometry? Well, technically, you could argue that point. But when it comes to thinking deductively, I would say you will use it your whole life long because you've learned a form of thinking. You break down things, look at all the component parts, and figure out what tools you need to solve it. Now, of course, with the academic competitions, it's not only they get a lot of practice, but there's no ceiling on how high they can go. They can compete against the other best students in the region, in Northeast Ohio, compete against the rest of the students in Ohio, in the Midwest, and eventually even nationally. So our students have competed on that level. Some of our students have won awards in the top 10 in the state and even in the country. But that's all according to their ability and their willingness to build up more tools. Most of the time that I spend with my Math Counts team is giving them more tools so they can look at more sophisticated problems, break them down, and come up with an answer. But it's that deductive process, and then it's the competitions that allow for more practice and more opportunities that we build really strong mathematicians. I always think it's kind of neat when we'll be going to Math Counts in about 2 weeks, and we'll compete against schools in which there's 500 eighth graders, and we bring 2. They have 700 seventh graders, and we have 1. We build a team because the kids will put the time in and the effort. They'll come in on Thursday afternoons. They'll come Saturday mornings from 9 to 12 because they enjoy it. But it's a part of lifting the ceiling in this subject so they can take math as far as they'd like to go.